Look up into the velvet black of the night sky. Beyond the glow of our cities, beyond the veil of our atmosphere, what you are truly seeing is a map of the impossible, a glittering testament to distances so profound they defy the very structure of our minds. Each point of light is a destination we cannot reach, a sun, a world, a galaxy forever beyond our grasp, and separating us from them is a wall, not a wall of matter or of energy, but of law, a fundamental decree woven into the fabric of existence itself that declares, "Thou shalt not travel faster than light." For all of human history, this has been our grandest dream, to slip the surly bonds of our home world, to cast off the anchor of gravity, and to sail the cosmic ocean. It is a story we have told ourselves since we first learned to speak, a narrative etched into our myths, our religions, our art. We are the children of explorers, the descendants of voyagers who crossed deadly oceans on fragile rafts of wood and hope. The drive to see what lies beyond the next horizon is not just a curiosity. It is the core of our identity. It is the engine of our species. The stars were our first calendar, our first gods, our first mystery. And as we grew, so did the ambition of our dreams. From crossing a continent to circumnavigating a planet, our reach expanded, but the goal always remained the same: to go further, to see more, to understand our place in the whole. In the 20th century, we finally touched the void. We walked on another world, a place of silent, magnificent desolation. We sent emissaries of metal and silicon out into the great dark robotic pioneers, carrying messages from their creators. The Voyager probes, now adrift in the interstellar medium, carry a golden record, the sounds and sights of our world. A message in a bottle cast into an ocean of unimaginable scale. It is a gesture of pure, unadulterated hope, a belief that one day we will follow. Our science fiction is saturated with this vision, gleaming starships that fold space and leap between galaxies in an instant, brave crews venturing into the unknown, encountering wonders and terrors. This is the future we have promised ourselves, a destiny where humanity is not confined to one small blue marble, but is a citizen of the cosmos, a member of a galactic community. The idea is so intoxicating, so deeply embedded in our culture, that we treat it as an inevitability, a technological hurdle we will one day overcome, just as we overcame the challenges of flight and fission. The ultimate speed limit, the speed of light, is seen as the final frontier, the last great barrier to our manifest destiny among the stars. The number itself is almost a form of secular prayer: 299792458 meters per second. It is the universe's ultimate velocity, the speed of causality itself. Albert Einstein, in a revolution that shook the foundations of physics, revealed this cosmic law to us. He showed that as an object with mass accelerates, its energy increases, and so does its resistance to further acceleration. Its inertia grows. As you approach the speed of light, this effect spirals out of control. The energy required to push you faster and faster climbs toward infinity. You would need all the energy in the entire universe to push a single grain of sand to the true speed of light. It is the most resolute no ever spoken by nature. And so we scheme. We devise clever workarounds. We dream of warp drives that bend the space in front of us, creating a wave we can ride like a cosmic surfer. We theorize about wormholes, cosmic shortcuts, tunnels through the fabric of space-time that connect distant points. We do everything we can to cheat the law, to find a loophole in the universe's most fundamental contract. Because the alternative, that we are marooned here, that the vast, beautiful, terrifying cosmos will forever remain a spectacle to be viewed only from afar, is almost unbearable. It speaks to a loneliness too profound to contemplate. But what if we have been looking at this all wrong? What if this ultimate barrier, this cosmic speed limit, is not a prison wall designed to keep us in? What if it is a shield, a form of fundamental universal protection engineered into the laws of physics from the first moment of creation? What if the prohibition against light-speed travel for massive objects is not a limitation on us, but a safeguard for everything else? A law that prevents a single object, a single civilization from gaining access to a power so absolute it could accidentally or intentionally unmake reality itself. This is the precipice of a terrifying new idea, a concept that emerges from the deepest, strangest corners of theoretical physics. It suggests that our dream of interstellar travel, the very ambition that defines our species, is a desire for a forbidden weapon of cosmic destruction. It proposes that attempting to travel at the speed of light would not just be an engineering challenge or even fatal for the traveler. It would be an act of universal vandalism, an assault on the very architecture of existence, a trigger that could initiate the collapse of physical law and shatter the continuity of space and time. To understand how we must abandon our comfortable everyday intuition, we must journey into a realm where our senses betray us and the logic of our world melts away like a dream upon waking. Let us imagine for a moment that we succeed. Through some unimaginable technology, some mastery of physics that is currently indistinguishable from magic, you build a ship. You board this vessel and you engage a drive that can ignore the problem of infinite energy. You begin to accelerate towards that ultimate, forbidden velocity. The journey does not begin with a bang, but with a whisper, as the very nature of time begins to warp around you. From the perspective of an observer watching you go, your clock would begin to slow down. This is time dilation, a proven consequence of relativity. The faster you move, the slower time passes for you relative to the stationary universe. At 90%, the speed of light time for you is passing at less than half the rate of the outside world. At 99.9%, a single day for you is almost a month for us. As you continue to accelerate closer and closer to that absolute limit, this effect becomes infinitely more profound. Your clock slows to a crawl, then to a near total stop. For every second that ticks by on your ship, millennia, then millions of years, then billions of years are flashing by for the rest of the cosmos. You are becoming unstuck from the river of time. But this is just the view from the outside. Inside your ship, from your perspective, something even more bizarre is happening. Looking ahead, the universe would compress. The distance to your destination, say the Andromeda Galaxy, would seem to shrink. This is length contraction, another pillar of relativity. The space in your direction of travel literally gets shorter. As you approach the speed of light, this contraction becomes absolute. The 2.5 million light-years to Andromeda would shrink to 1,000 light-years, then to a single light-year, then to the length of a football field, then to nothing at all. From your point of view, at the precise moment you reach light speed, you would be everywhere along your path at once. Your departure and your arrival would become the same event. Think what this truly means. The concept of a journey, of a duration, of a before and after, ceases to have any meaning for you. You exist in a state of instantaneous transit across the cosmos. But for the universe, you are a paradox. You are a moving object for which time has stopped. You have effectively achieved a form of immortality, but it is a terrifying frozen kind of eternity. You are a statue of matter and energy moving at the speed of thought, but experiencing no passage of time whatsoever. You are a ghost in the universal machine. The implications for causality are catastrophic. Causality is the most fundamental principle of our universe. The rule that an effect cannot happen before its cause. A glass cannot shatter before it is dropped. A star cannot go supernova before its core collapses. This sequence of events is the bedrock of reality. It is what allows for a coherent, understandable existence. The speed of light is the enforcement mechanism for this law. It ensures that no signal or influence can travel faster than its cause, preventing the universe from descending into a chaos of paradoxes. But you, in your light-speed vessel, have become a causality-breaking object. Because time has stopped for you, the entire history and future of the universe exist for you in a single frozen moment. From your impossible perspective, the Big Bang and the final entropic heat death of the cosmos are simultaneous events. You are a needle threaded through the entire tapestry of time from the first instant to the very last. You could, in theory, witness the effect of an event before its cause has even occurred in the normal flow of time. You would not simply be a traveler, you would be a mobile temporal anomaly, a rupture in the sequence of what was and what will be. The universe may have no way to resolve such a paradox. Its logical structure, the very code upon which it runs, would encounter a fatal error. The presence of your ship could propagate a wave of incoherence, a ripple of non-logic that destabilizes the temporal fabric everywhere. The past could change, the future could cease to be determined, the very meaning of existence could unravel, and this is only the first of the horrors we would unleash. Let us consider another consequence of Einstein's equations. The famous E equals mc squared energy equals mass times the speed of light squared. This tells us that mass and energy are two faces of the same coin. But the full equation for a moving object is more complex. It shows that an object's energy, its kinetic energy from motion, and its rest energy from its mass, grows with its speed. As you approach light speed, this energy value skyrockets towards infinity. Your ship, which started with a mass of a few thousand tons, now behaves as if it has the mass of a planet, then a star, then a galaxy, then all the galaxies in the observable universe combined. You are no longer a vessel. You have become a point of infinite energy, a singularity not of gravity like a black hole, but of pure, unimaginable kinetic force. What happens when this object you interacts with anything, even a single stray hydrogen atom floating in the vacuum of space? From the atom's perspective, it is being struck by an object with literally infinite energy. The collision would be an event of violence so extreme we lack the language to properly describe it. It would not be an explosion in any conventional sense. It would be a conversion of infinite kinetic energy into other forms. A flash of gamma rays so powerful it could sterilize an entire galaxy. A shower of exotic particles that would rewrite the laws of physics in their immediate vicinity. The impact would create a new Big Bang, but a cancerous localized one, erupting from a single point in space-time. A universe-destroying event triggered by a speck of dust. You would become the most dangerous thing to have ever existed. A single touch from your ship would be an act of utter annihilation. It would not just destroy a planet or a star, it would erase it from the very fabric of reality, unleashing a cascade of energy that would then propagate outwards itself, traveling at the speed of light, a sphere of absolute destruction expanding through the cosmos, a bubble of nothingness consuming everything in its path. The dream of reaching the stars would become the mechanism for extinguishing them. Our desire to connect with the universe would grant us the power to single-handedly destroy it. The safeguard, the speed limit, was there to protect the universe from us, from the catastrophic potential hidden within every particle of matter. But the true danger may be even more fundamental, more subtle, and more terrifying. It may not be about time or energy, but about the very nature of space itself. We think of space-time as a stage, a backdrop upon which the cosmic drama unfolds. But modern physics tells us it is a dynamic physical entity. It can bend, it can stretch, it can ripple. It is a fabric woven from principles and dimensions we can barely comprehend. A ship traveling below light speed is moving through this fabric. It is a boat sailing on the surface of an ocean, but an object at the speed of light is a different beast entirely. It would no longer be moving through space-time. Its very existence would be a challenge to space-time. The infinite energy and the breakdown of temporal logic would mean that the fabric could no longer support your existence. Imagine a flaw, a tear in a piece of silk. Your ship would become a moving, propagating tear in the cosmic fabric. You would be a wound in reality, a place where the rules of physics are broken, and this wound would be traveling at the speed of light. It might be that space-time itself would recoil from you. The universe, like a living organism, might deploy a form of immune response to this violation of its core principles. The laws of physics around your ship could actively rewrite themselves in an attempt to contain the paradox you represent. Perhaps a bubble of false vacuum would form around you, a region of space where the fundamental constants have shifted to a new, more stable state, a state that might be incompatible with the existence of matter as we know it. Your ship would be instantly annihilated, but the bubble, this zone of new physics, would now exist, and models suggest that such a bubble, once formed, would expand outwards in all directions at the speed of light. It would be a silent, unstoppable wave of reality change. As it washed over a star, a planet, a galaxy, the atoms themselves would be forced into a new configuration. The very chemistry that allows for life, the very nuclear forces that hold suns together, would be erased and replaced. It would not be destruction by fire or force. It would be a far more complete form of erasure, a conversion of our universe into another alien one, a universe in which we could not exist. Our single act of hubris, of breaking the ultimate law, would trigger the end of everything for everyone everywhere. This is the chilling possibility we are forced to confront. That the cosmos is not a playground for our future ambitions, but a finely tuned mechanism governed by laws of breathtaking power and fragility. Laws that are not merely suggestions, but absolute decrees that maintain the integrity of existence. The speed of light is not a goal to be achieved. It is a warning sign, a cosmic skull and crossbones telling us of a danger so profound that it dwarfs any threat we have ever conceived. It is the universe telling us that some doors are locked for a reason, that some powers are not meant to be wielded, and so our grandest dream is turned on its head. The quest for the stars becomes a flirtation with oblivion. The desire to travel at light speed is revealed to be a suicidal and indeed omnicidal impulse. The story of humanity may not be about breaking our bonds and conquering the galaxy. It may be about learning to accept our limitations, about finding wisdom in restraint, about understanding that our home, this tiny, fragile world, and our slow, ponderous journey through time is a gift of cosmic stability, not a prison of cosmic law. Ahead of us lie the theories that explain this terrifying potential. We will dive into the mathematics of relativity, the paradoxes of quantum mechanics, and the bleeding edge of string theory. We will investigate the very fabric of the void to understand why the universe is built this way, why our greatest dream may also be our ultimate nightmare. The journey to understand why traveling at the speed of light could destroy the universe has just begun. There is a speed limit hardwired into the cosmos. It is not a law written in the books of humanity. It is a fundamental rule etched into the fabric of reality itself, a boundary that governs every quantum shudder, every stellar explosion, and every silent thought that flickers through your mind. This is the ultimate speed, the absolute velocity, 300,000 kilometers per second, the speed of light. For most of our history, we thought of speed as a simple affair. An object in motion could always be made to move faster. If you were on a train, you could walk forward. Your speed and the train's speed would simply add together. This was the universe according to Isaac Newton, a grand, predictable clockwork machine, Space was an empty stage, a rigid and unchanging grid. Time was a universal river flowing at the same steady rate for everyone. In this tidy, intuitive cosmos, there was no ultimate speed limit. You just needed a powerful enough engine, a strong enough push. You could, in theory, accelerate forever. Chasing down a beam of light was a perfectly reasonable proposition. You would just need to travel very, very fast to catch it. It was a universe of absolutes of common sense, and it was profoundly, beautifully, and utterly wrong. The first clue that something was amiss in this clockwork reality came not from a grand theoretical breakthrough, but from a puzzle, a persistent nagging anomaly that refused to be explained. Physicists in the late 19th century were trying to measure the Earth's motion through a mysterious substance called the luminiferous ether. This was thought to be the invisible medium that light waves traveled through the way sound waves travel through air. If it existed, then the speed of light should appear different depending on whether we were moving towards the light source or away from it. Just like the pitch of a siren changes as an ambulance passes you. The experiment was a delicate and brilliant piece of engineering. It used mirrors and beams of light to detect the slightest variance. Scientists expected to find a small but measurable difference. They found nothing. They tried again with more precision. Still nothing. They tried at different times of the year, as the Earth orbited the Sun in different directions. The result was always the same, utterly stubbornly the same. The speed of light refused to change. It didn't matter if you were racing towards the light source or fleeing from it at incredible velocity. It didn't matter what the source itself was doing. The light from a distant, receding galaxy travels at the exact same speed as the light from a flashlight in your hand. This was not just a strange result, it was an impossible one. It was a cosmic crime scene where the evidence defied all logic. It broke the simple additive rules of Newton's universe. It suggested that reality was operating on a set of principles so alien, so contrary to our everyday experience that we had failed to even conceive of them. The universe was not a simple clockwork machine. It was something far stranger and far more magnificent. The solution came from an unexpected place. Not from a tenured professor in a prestigious university, but from a young clerk in the Swiss patent office, a man who spent his days examining technical drawings for new inventions and his nights wrestling with the very nature of existence. His name was Albert Einstein. He began not with complex mathematics, but with a simple question, a thought experiment. What would you see if you could ride alongside a beam of light? According to Newton's rules, you should be able to catch it. And if you did, the light wave should appear to you as a frozen, stationary wave. A motionless ripple of electromagnetic energy hanging in space. But the existing laws of electromagnetism, Maxwell's equations, forbade this. They were clear light, by its very nature, must always move at light speed. It could never be seen at rest. Here was the contradiction, the central paradox. Newton's laws of motion and Maxwell's laws of electromagnetism could not both be right. One of them had to break. Einstein, in an act of supreme intellectual audacity, chose to trust the evidence of light. He made a bold and revolutionary assumption. What if the speed of light in a vacuum is constant? What if it is the one true absolute in the entire universe, constant for all observers, everywhere, always? If that single radical idea were true, then the consequences would be catastrophic for our old understanding. If the speed of light refuses to change, something else must. Something we thought was rigid and absolute. Einstein realized what had to give way. It was the very stage upon which the cosmic drama unfolds, space and time. He proposed that space and time are not separate independent entities. They are not a fixed background. Instead, they are interwoven into a single dynamic four-dimensional fabric, a continuum he called space-time. And this fabric is not rigid, it is malleable, it is relative. It can be stretched, compressed, warped and distorted. And what distorts it? Motion. The universe, Einstein declared, is a place where two observers, moving at different speeds, will experience reality itself in fundamentally different ways. They will disagree on the length of objects. They will disagree on the passage of time. And yet both of them would be correct. This was the birth of special relativity. And at its heart was a new understanding of the speed of light. The constant c is not merely the speed of photons, that is just one of its manifestations. C is something far more profound. It is the speed of causality. It is the maximum velocity at which any information, any effect, any signal can travel through space-time. It is the universe's ultimate traffic law, a law that nothing can break. It ensures that cause always precedes effect. It prevents the universe from descending into a chaos of paradoxes. It is the fundamental operating speed of reality itself, the rhythm to which the entire cosmos must dance. And this ultimate speed limit is not a suggestion, it is an impassable wall, especially for anything like you or me made of matter. The reason for this lies in Einstein's most famous and perhaps most misunderstood equation, E equals mc squared. We often think of this equation in the context of awesome destruction, the key to unlocking the power of the atom. But its true meaning is far deeper and far more subtle. It tells us that energy and mass are not separate things, they are two faces of the same coin. Mass is a form of concentrated, condensed energy, and energy, in a sense, has mass. This is the secret to why reaching light speed is impossible for a physical object. Think about what it means to accelerate something. You are pumping kinetic energy into it. You are adding energy of motion. In our old Newtonian world, this was simple. More energy meant more speed in a linear, predictable way. But in Einstein's universe, the story is very different. As you push an object, as you pour energy into it, that added energy has to go somewhere. And according to E equals mc squared, that energy contributes to the object's mass. So as an object moves faster, its mass increases. At everyday speeds, this increase is infinitesimal, unnoticeable. A commercial jetliner flying at 900 kilometers per hour is only about 1 nanogram heavier than it is on the ground. But as you approach the cosmic speed limit, the effects become dramatic. They become staggering. Imagine a starship, a vessel capable of incredible acceleration. You begin your journey, 90% of the speed of light. The ship's mass from the perspective of a stationary observer has already doubled. To accelerate it further requires twice the energy it would at rest. You push harder, pouring unimaginable power into the engines. 99% of the speed of light. The ship's mass has now swelled to over 7 times its original value. It is becoming monumentally heavy, sluggish, resistant to change. The universe itself is fighting your attempt to go faster. You press on, 99.9%. The mass is now 22 times greater, 99.999%. The mass has multiplied by more than 220. Your ship, once a sleek vessel, now behaves as if it has the mass of a moon. Each tiny increment of speed you gain requires a titanic, ever-escalating input of energy. The energy you pour in is not primarily making you faster. It is almost entirely being converted into mass. You are fighting against a law of cosmic physics that grows stronger the harder you fight it. The finish line, the speed of light itself, recedes from you. To reach it, to bridge that final infinitesimal gap, would require an infinite amount of energy, because at the speed c, the object's mass would become infinite, and you cannot accelerate an infinite mass. The speed of light is not a goal to be reached. It is a horizon you can approach forever but never ever touch. It is the domain of massless particles alone, like photons. For everything else, it is the absolute unbreachable boundary of existence. But the consequences of this cosmic chase are not just about mass and energy. As you accelerate into this extreme realm, the very fabric of space-time around you begins to contort in bizarre ways. Reality itself warps and bends to uphold the constancy of c. The first and most famous of these effects is on time. As you move faster through space, you move slower through time. This is not a metaphor. It is a physical reality. It's called time dilation. Aboard your starship, accelerating towards the light speed barrier, the clocks would appear to you to tick normally. Your heart would beat at its usual rhythm. You would age at your normal rate. But to someone watching you from Earth, your time would be running slow. Your every movement, every tick of your clock, every breath you take would appear to be happening in a kind of cosmic slow motion. The faster you go, the more sluggish your time becomes to an outside observer. At 99.9% of light speed, for every hour that passes for you on the ship, more than 22 hours would have passed back on Earth. Your journey of a single day would be a 3-week eternity for those you left behind. Go even faster, closer still to the limit, and the effect escalates exponentially. At 99.9999% of c, 1 year of your time on the ship would correspond to over 700 years on Earth. You could travel to the nearest star system, Proxima Centauri, a journey of just over 4 light years. From your perspective, traveling at this incredible velocity, the trip might take only a matter of days. You would arrive, turn around, and come back. For you, it would be a short expedition, a week out of your life. But when you returned to Earth, you would find a world transformed. Everyone you ever knew would be gone. Centuries would have passed. Civilizations would have risen and fallen. The planet itself might be unrecognizable. You would have become a traveler not just through space, but through time. A ghost from a distant past arriving in a future you could never have imagined. Time dilation is a one-way ticket to the future, a profound and lonely journey from which there is no return to your own time. The universe protects its ultimate speed limit by stretching the very seconds and minutes we use to measure it. But time is not the only thing that becomes flexible. Space itself, the 3 dimensions we inhabit, also begins to distort. As your ship approaches light speed, the universe in front of you appears to compress in the direction of your travel. This is length contraction. From your perspective on board, the ship's dimensions are normal, but to someone on Earth, watching you streak past your ship would appear squashed, flattened, impossibly thin. More strangely, the universe you are flying through would change its shape for you. The distance to your destination would literally shrink. That 4 light-year journey to Proxima Centauri. As you approach the speed of light, that distance from your point of view contracts to a few billion kilometers, then a few million. Then, in the final fractions of a percentage point, the distance ahead of you shrinks almost to nothing. It's as if space-time itself is clearing a path, squeezing the cosmos to allow you to cross vast distances in your compressed time frame. Stars would no longer look like points of light. They would appear as flattened, distorted streaks. Galaxies would warp into strange compressed ellipses. The entire visual universe would become a funneled, distorted tunnel of light, its geometry twisted by your incredible velocity. You are not just moving through the universe. Your motion is actively reshaping the universe you perceive. The rigid grid of Newton's space is revealed to be a fluid, a medium, that bends to the will of near light-speed travel. These 2 effects, time dilation and length contraction, are 2 sides of the same coin. They are the tools space-time uses to enforce the law of c. No matter how fast you are going, if you were to measure the speed of a beam of light passing you, you must get the same answer, 300,000 kilometers per second. To make this mathematical certainty hold true, your rulers must shrink, and your clocks must slow down. Your very instruments of measurement, your perception of space and time are altered by your motion to preserve this one cosmic constant. It is an elegant, mind-bending, and absolute conspiracy of physics. And as these distortions of space and time reach their zenith, so too does the accumulation of energy in your vessel. Let's return to the staggering increase in mass. This isn't just a mathematical quirk. It is terrifyingly real. The kinetic energy of your ship, the energy of its motion, is escalating towards infinity. Consider the energy scales at play. A single kilogram of matter moving at 99.9% of light speed carries more kinetic energy than all the world's nuclear arsenals combined. Now imagine your starship weighing thousands of tons. As it approaches sea, it ceases to be just a vessel. It transforms into a concentration of energy so vast, so immense, that it begins to rival the output of stars. The energy required to get it there is already astronomical. But the energy it now carries is something else entirely. It is a weapon of cosmological proportions, an object with near-infinite mass and near-infinite kinetic energy, a point-like missile containing the power of a supernova. It is an entity existing in a moment of nearly frozen time. It perceives the universe as a flattened, compressed corridor, and it is saturated with a destructive potential so profound it challenges our understanding of physical law. This is the precipice, the place where the elegant theories of relativity begin to hint at something monstrous. We have established the rules of the ultimate chase. We know the boundary is absolute, the wall impassable, but we have also created a theoretical object of unimaginable power, an object that embodies the paradoxes of near-light speed travel. It is a rupture in the fabric of space-time, a needle of infinite energy poised to strike. The laws of physics prevent this object from ever truly reaching the speed of light. But what if it could? Or what if something moving so close to that speed were to interact with our world? What happens when you unleash an object carrying the energy of a star? It is not just about a powerful collision. It is about what such an extreme concentration of energy and mass does to the very structure of space-time itself. The consequences are not merely destructive. They are apocalyptic on a scale that redefines the word. They threaten the laws, the constants, and the very existence of the universe as we know it. The beautiful, simple dream of crossing the stars at light speed is a lie. It is a siren song that masks a terrifying truth, a truth written not in philosophy, but in the cold, hard calculus of creation. To travel at the speed of light is not to become an explorer. It is to aim a weapon at the very heart of the universe, and to pull the trigger. The journey begins with a cost, not a cost measured in treasure or resources, but in the fundamental currency of reality itself, energy. Albert Einstein gave us the master equation, the cosmic ledger that balances matter and energy, E equals mc squared. In its elegant script, it tells a story of unimaginable potential. But for the would-be star traveler, it is a death sentence. The equation hides a cruel secret, a clause in the fine print of physics. As you accelerate, as you push your vessel closer and closer to the ultimate speed limit, something strange begins to happen. Your mass, the very substance of your ship and your body, begins to increase. It is not an illusion. It is a physical transformation. The universe resists your motion, and it resists by making you heavier. Imagine you are at the helm of a starship, a vessel no larger than a family car. At a standstill, its mass is what you would expect, a few tons. You engage the engines, you accelerate, 10% of light speed, 20, 50. Your relativistic mass grows, but slowly at first, almost imperceptibly. The ship feels heavier to the cosmos. It demands more and more energy for each new burst of speed. Now you push into the true depths of relativistic travel. 90% of the speed of light. Your ship's mass has more than doubled. The energy required to push it further grows exponentially. The fuel you burn now gives you less and less acceleration. You are fighting an uphill battle against infinity. 99%. Your mass is now 7 times what it was at rest. Every atom in the hull, every circuit, every molecule of your own body is 7 times more reluctant to go any faster. To reach 99.9%, your mass inflates to over 22 times its original value. The energy you've expended is already monumental, more than all the power humanity currently generates in a year, all to push a single small craft. But this is where the dream truly shatters. This is where the numbers become a litany of the impossible. Consider a single grain of sand weighing just 1 milligram. Let us try to accelerate this single tiny speck to 99.9 followed by 9 more 9% of light speed, infinitesimally close to the cosmic speed limit. The energy required to perform this seemingly simple act would be greater than the detonation of the most powerful nuclear weapon ever built, the Tsar Bomba. 50 megatons of explosive fury, all to nudge 1 grain of sand to the edge of possibility. Now scale that up. Not a grain of sand, but a person, an 80-kilogram astronaut. To accelerate that single human being to the same velocity would require more energy than the entire world consumes in a century. And for a true starship, a vessel designed to carry a crew supplies a habitat. The energy required defies any rational scale. You would need to harness the full blazing output of our sun, not for a second or a day, but for months, years. All its ferocious thermonuclear power perfectly captured and focused to propel one ship on one journey. Where could such power possibly come from? The most potent reaction known to physics is the total annihilation of matter and antimatter, 100% conversion of mass to energy. Even with this perfect theoretical fuel source, a starship aiming for near luminal speeds would need a fuel tank. Containing a mass of antimatter equal to the ship itself, it would be a vessel built half of matter, half of a substance so volatile that a single stray atom of contact would trigger an explosion of apocalyptic scale. We are no longer in the realm of engineering. We are in the realm of cosmic absurdity. The universe, it seems, has established a law of conservation not just of energy but of its own structure. The speed of light is not merely a limit, it is a fiercely guarded border, and the toll to cross it is infinity itself. The cost is a form of bankruptcy on a cosmic scale. But let us assume for a moment that this cost could be paid, that some future civilization finds a way to wield the power of stars. The problem of energy is only the first seal to be broken. What comes next is far, far worse, because the same physics that makes your journey so expensive also transforms you, the traveler, into the most devastating weapon conceivable. That unimaginable quantity of kinetic energy you've accumulated doesn't simply vanish. It is carried with you. It becomes a part of you. You are not just a fast-moving object. You are a vessel of catastrophic potential. Think back to that single grain of sand. We calculated the staggering energy needed to get it to near light speed. Now imagine what happens when it arrives at its destination, or when it simply hits something along the way. All of that stored kinetic energy, the equivalent of a 50 megaton nuclear warhead, is released in an instant, a flash of plasma and radiation that would scour the surface of a small moon. 1 milligram of dust becomes an extinction-level event. This is the terrible symmetry of relativity. Anything moving at such an immense velocity is by its very nature a kinetic bomb. Your starship, the one you powered by harnessing a sun, is now a planet killer. It is an object carrying more destructive power than all the nuclear arsenals on Earth combined, and not by a small margin, by orders of magnitude. The impact of your vessel, even at a fraction of its full speed, would not just create a crater, it would crack a planet's crust. It would boil oceans, ignite the atmosphere, and send shock waves through the very mantle of a world. An accidental collision would be an act of planetary annihilation, a slight miscalculation in your trajectory, a navigational error of 1,000th of a degree, and you could inadvertently wipe out a world teeming with life. You, the hopeful explorer, would become a god of death, the bringer of a silent, unforgiving apocalypse from the void. The cosmos is a vast shooting gallery, and a relativistic starship is the ultimate bullet, an astoundingly precise planet-shattering projectile. The responsibility would be unbearable. Every star system you approach would become a potential victim. Every asteroid belt a minefield where one mistake could trigger a catastrophe for an unsuspecting solar system millions of years later. How could any civilization dare to launch such a vessel? How could they accept the risk, knowing that their quest for knowledge could result in the unintentional genocide of another species? The speed of light doesn't just demand infinite energy, it demands a kind of moral perfection, an infallibility that is likely impossible. But even if you could solve the energy problem, even if you could navigate with the precision of a deity, the universe has another, more intimate and far more relentless way to destroy you. The final horror is not what you do to the universe, it is what the universe does to you. We think of space as empty, a vacuum. It is a profound misconception. The void between the stars is not a true void. It is a tenuous, almost imperceptible mist of gas and dust. On average, in our galactic neighborhood, there is about one single atom of hydrogen for every cubic centimeter of space. One atom. At the speeds we travel, this is less than nothing. The Apollo missions flew through this medium without even noticing it. But when you are traveling at 99.99% of the speed of light, that single lonely atom becomes a fearsome threat. From your perspective on the ship, you are standing still. It is the universe that is rushing toward you at an impossible velocity. That single hydrogen atom is no longer a gentle drifter. It is a subatomic particle fired at you from the most powerful accelerator ever conceived. It strikes the hull of your ship with the energy of a cosmic ray. And you don't hit just one. A ship with a front-facing surface area of just 100 square meters would collide with trillions of these hydrogen atoms every single second. It is not a gentle mist. It is a constant, unyielding barrage of high-energy radiation, a storm of particle impacts that would steadily sandblast your vessel at a molecular level. The forward sections of your ship would be subject to a process of constant erosion, a relentless ablation that would eat away at any known material. But the erosion of the hull is the least of your worries. Each impact generates a secondary shower of particles, X-rays, gamma rays. This lethal radiation would flood the interior of your craft. It would penetrate any realistic amount of shielding. It would slice through the bodies of the crew, shredding DNA, unraveling the delicate machinery of life. Your ship would become a mobile radiation chamber, a flying tomb sterilized by the very space it sought to cross. To survive, you would need a shield of impossible thickness and density, perhaps meters of solid lead or some exotic undiscovered material. But remember Einstein's law. Every kilogram you add to your shield increases your mass, and every increase in mass drives the energy requirement for your journey even further toward infinity. It is a vicious, inescapable circle, a cosmic checkmate. And we have only considered the single atoms of hydrogen. What about the dust? interstellar space is also filled with tiny grains of silicate and carbon, specks smaller than the width of a human hair, micrometeoroids. At relativistic speeds, these are not minor annoyances, they are weapons of immense power. Let's return to our 1 milligram grain of sand. We know the impact releases the energy of a nuclear bomb. Your journey to the nearest star, Proxima Centauri, would take you across 4 light-years of space. Even in the clean, sparse medium between stars, the chances of hitting a particle of this size, or larger, are not zero. They are terrifyingly high. You would be flying through a minefield, a 3-dimensional field of invisible, silent, relativistic bombs. You could not see them coming. They travel at the same speed you do. There would be no warning, no chance to evade, only a sudden, instantaneous flash of incandescent plasma, a detonation that would obliterate the forward section of your ship. And if the particle were larger, the size of a pebble, the impact energy would be equivalent to hundreds of nuclear weapons, enough to vaporize your entire vessel in a fraction of a millisecond. Erased from existence by a piece of cosmic gravel, so you have an impossible energy requirement. You have turned your ship into a weapon of mass destruction. And you are flying through a minefield of atomic artillery and planet-shattering dust grains. It would seem the universe has built a fortress around its stars, a defense in depth against any traveler bold enough to challenge the tyranny of distance. But it has one final, ultimate defense, a barrier so fundamental, so perfectly woven into the fabric of reality, that it may represent the final absolute veto against light-speed travel. It is a weapon disguised as a whisper, a faint, cold, and utterly ubiquitous glow that fills all of space. It is the cosmic microwave background, the afterglow of the Big Bang, the oldest light in the universe. It is composed of photons, particles of light that have been traveling since the dawn of time, stretched and cooled over 13.8 billion years into harmless, low-energy microwaves. Its temperature is a mere 2.7 degrees above absolute zero. It is the cold, fading echo of our own creation. How could this gentle, ancient light possibly be a threat? The answer lies in one of the most familiar concepts in physics, the Doppler effect. We hear it in the changing pitch of a siren as it passes by. As the source of a wave moves towards you, its waves are compressed, their frequency increases. As it moves away, the waves are stretched, their frequency decreases. Light behaves in the same way. Light from an object moving towards you is compressed to a higher frequency. It is shifted toward the blue end of the spectrum, a blue shift. Light from an object moving away is stretched to a lower frequency, a red shift. At normal velocities, this effect is small, almost unnoticeable, but at 99.999% of the speed of light, the Doppler effect becomes extreme, catastrophically extreme. From the perspective of your ship, the ancient cold photons of the cosmic microwave background are no longer cold. The ones in front of you, the ones you are flying into, are rushing at you at nearly the speed of light. They are not red-shifted, they are blue-shifted. And they are blue-shifted so intensely, so violently, that they are transformed. The gentle, long wavelength microwaves are compressed past infrared, past visible light, past ultraviolet. They are squeezed into X-rays, and as you push ever closer to light speed, they become gamma rays, the most energetic and destructive form of light in the universe. The very space in front of you begins to glow with lethal radiation. The faint echo of the Big Bang transforms into a forward-facing furnace, a wall of high-energy gamma radiation pouring over your ship, a constant, inescapable headwind of death. There is no shielding from this. This isn't a particle you can block or a piece of dust you might dodge. It is the very fabric of space-time itself becoming hostile. The faster you go, the hotter and more intense this radiation becomes. Pushing toward the speed of light is like flying directly into the heart of a quasar. The universe itself actively fights to vaporize you. It is the ultimate irony. In your quest to see the cosmos, you accelerate to a speed where you can no longer see anything. Your forward view is not a majestic starscape. It is a blinding, searing, white-hot wall of lethal energy, a self-made star consuming you. This isn't an obstacle that can be engineered around. It is a fundamental consequence of motion through our universe, a final, unbreakable law enforced by the ghost of creation itself. The light of the Big Bang stands guard, and it says, "You shall not pass." For all of our history, we have been prisoners of the present, bound by an invisible, unrelenting current we call time. It carries us forward from one moment to the next, from birth to life to death. But what if it wasn't a prison? What if it was a fortress? What if the very law that seems to confine us is the only thing protecting reality from falling apart? We have exhausted the physics of the possible. We have seen how traveling near the light barrier invites ruin, how it demands infinite energy, confers infinite mass, and turns the gentle dust between the stars into lethal radiation. The universe, it seems, has built a wall around the speed of light. A cosmic prohibition enforced by the laws of nature itself. But humanity is a species of rule breakers. So let us imagine for a moment that we find a loophole, a clever circumvention of cosmic law, not by accelerating through the barrier, but by stepping around it. Perhaps a warp drive, a technology that folds space-time like paper, bringing two distant points momentarily together. Or a stable wormhole, a tunnel through the fabric of reality, a secret passage from one side of the cosmos to the other. Maybe we discover exotic matter with its negative mass, a substance that could theoretically prop open such a gateway. Suddenly, the journey to Alpha Centauri is not a generation ship's dream, but a week-long commute. The Andromeda Galaxy is no longer a faint smudge of light, a destination 2.5 million years away. It becomes a new frontier, reachable within a human lifetime. The universe would shrink. Its vast, lonely distances would collapse. We would become true masters of our cosmic neighborhood, a Type 3 civilization striding between galaxies like gods. This is the promise, the ultimate technological salvation. But every forbidden fruit hides a poison, and the poison hidden within superluminal travel is not physical. It is not about energy or radiation or engineering. It is metaphysical. It is a venom that attacks the very logic of existence. Because in cheating the speed of light, you have not just broken a speed limit, you have broken the sequence of time itself. You have shattered the most fundamental law of the universe, the unbreakable covenant of cause and effect. Think of it. A rock is thrown, a window shatters. The throw is the cause. The shattering is the effect. One must always precede the other. This isn't just an observation. It is the central pillar of sanity. It is the axiom upon which all of reality is constructed. A star collapses under its own immense gravity. Then and only then does it erupt into a supernova. A thought forms in your mind a pattern of firing neurons. Then and only then do you speak a word or take a step. From the grandest cosmic explosions to the most intimate decisions, the universe adheres to this one sacred direction. First the cause, then the effect. The arrow of time flies in only one direction. But Einstein's relativity revealed something astonishingly strange. It showed us that space and time are not separate things. They are woven together into a single four-dimensional fabric space-time, and the speed of light k is not merely a velocity. It is the fundamental conversion rate between space and time. It is the speed at which causality itself propagates through the cosmos. The light from a distant exploding star does not just carry an image, it carries the information of the event. The news of the star's death travels at the speed of causality. Nothing can deliver that news faster. The effect our seeing the explosion cannot happen before the information arrives. Here is where our dream of interstellar empire turns into a nightmare. Imagine we build our first warp ship, the Prometheus. It is poised to make a journey of 10 light years to the star Sirius. Using its drive, it can make the trip in a single day. It arrives, sends a simple radio message back to Earth. We have arrived. That message, traveling at the speed of light, will take 10 years to get home. No problem there. The arrival happens long before the effect, the reception of the message on Earth. The arrow of time holds. The universe remains sane. But relativity introduces a complication, a profound and terrible one. The concept of simultaneity, the idea of two events happening at the same time, is not absolute. It depends entirely on your frame of reference, on how you are moving relative to the events you are observing. To an observer on Earth, the Prometheus is left then, it arrived a day later. But to another observer flying past our solar system in a powerful ship at a significant fraction of the speed of light, the sequence of events can appear different. Their unique motion through space-time alters their perception of time itself. For that second observer moving in just the right way, the order of events can actually reverse. From their perspective, the radio message from Sirius, the one saying, "We have arrived," is received by Earth. And then days later, in their reference frame, they witness the Prometheus leaving Earth in the first place. The effect has preceded the cause. The answer has arrived before the question was ever asked. This isn't just a trick of perception, a mere optical illusion. According to the mathematics of relativity, their frame of reference is just as valid, just as real as our own. In their reality, time flowed backwards. And if it is possible in one valid frame of reference, it is possible in all. The moment one object, one particle, one ship outpaces causality, the entire concept of a universal past, present, and future dissolves. It shatters into an infinite number of contradictory timelines. Suddenly, with this technology, we can do more than just send a message. We can send it to our own past. Imagine a more advanced scenario. A ship warps 20 light years away to the star Vega. It immediately sends a message back to Earth using a faster-than-light transmitter. This message, let us say, contains tomorrow's winning lottery numbers, or the details of a catastrophic stock market crash. From a certain reference frame, that message arrives on Earth yesterday. You receive the information, you act on it. You prevent the crash, or you become impossibly wealthy. But this creates a howling logical paradox. If you prevent the market crash, then there is no longer a crash to report. The original reason for sending the message back in time has vanished. So why was the message ever sent? If it was never sent, you never receive it. If you never receive it, you cannot act to prevent the crash. The crash then happens, which means the message is sent, which means you receive it and you prevent the crash. The logic folds in on itself, eating its own tail. A is true because of B, but B is true because A is false. It is an impossible, unbreakable loop of contradiction. The universe is being asked to be both a circle and a square at the same instant. It is a request that cannot be fulfilled. This isn't a clever puzzle. It is a fundamental violation. It is a cosmic short circuit in the wiring of reality. And it would not be confined to a single event. A universe where causality can be violated is a universe without a coherent history. The past is no longer a fixed, unchangeable landscape. It becomes a shimmering, unstable mire of possibilities. Every event is perpetually at risk of being undone by its own future. Consider the most famous paradox of all, the grandfather paradox. You build a time machine, an FTL ship that can traverse time as well as space. You journey into the past and prevent your own grandfather from meeting your grandmother. Therefore, you are never born. But if you were never born, you could never have built the time machine. You could not have gone back to interfere. Your grandparents meet, fall in love, and you are eventually born, only to build the time machine and travel back to prevent your own existence. It is the ultimate act of self-annihilation, an ontological suicide. A universe that permits this is not a universe. It is a madhouse of space-time. It is a place where events happen for no reason. A window could shatter spontaneously because in a different timeline, a rock that was never thrown in this one was. A person could flicker out of existence, their entire causal history erased by a future that will now never happen. History itself would cease to be a record. It would become an open battlefield where armies of contradictory events wage an endless war over what was, what is, and what will be. The implications spiral outwards, consuming everything. The very laws of physics which we have painstakingly uncovered are built on the bedrock of causality. They are deterministic. If we know the initial conditions of a system, we can predict its future state. Throw a ball with a certain force and angle and we know where it will land. This is only possible because the cause, the throw, reliably produces the effect, the landing. But in a superluminal cosmos, this foundational principle is gone. A scientist in a laboratory could run an experiment, and in the middle of it, a signal arrives from the future containing the results of that very experiment. But those results might influence how the scientist conducts the rest of the test, thus changing the outcome, invalidating the message they already received. The scientific method, the very process of discovery, becomes impossible. How can you test a hypothesis when the outcome can reach back and alter the conditions of the test itself? Every equation would contain a seed of its own undoing. The universe would cease to be governed by consistent, knowable rules. It would be governed by chaos, whim, and paradox. The destruction we are talking about is not an explosion. It is not a big crunch or the heat death of the cosmos. It is something far more profound, far more total. It is the annihilation of information. It is the death of logic. The universe is at its most fundamental level a story of energy and matter unfolding through time. It has a beginning, the Big Bang, a middle, its long and stellar life, and an end still unwritten. Causality is the grammar of that story. It is the structure that ensures the narrative makes sense, that sentences follow one another in a coherent order. A universe with faster-than-light travel is like a book where every page is constantly rewriting every other page, where the end can erase the beginning, where characters can be unborn by their own actions. The book would become an incoherent jumble of letters. The story would be lost. The information that defines our cosmos, the position of every star, the momentum of every particle, the memory in every mind, would be trapped in an infinite feedback loop of contradiction. There would be no single objective reality. Only a quantum foam of possibilities endlessly branching and collapsing with no stable timeline to give it form or meaning. This is the ultimate secret that Einstein's equations whisper to us. The speed of light is not a barrier to be broken. It is the wall of the dam that holds back the ocean of chaos. It is the operating system of reality, the one line of code that says, what is done is done. It is the law that gives time its arrow history, its permanence, and the future its mystery. By seeking to outrun a photon, we would not be liberating ourselves. We would be committing the ultimate act of cosmic vandalism. We would be taking the ordered, magnificent, and comprehensible universe that has evolved over 13.8 billion years and unraveling the very thread of its existence. The cosmos would not be destroyed in fire or ice. It would simply cease to make sense. And in a universe without logic, without a past, without a future, what is the difference between that and non-existence? The price of cheating the light barrier, it turns out, is the universe itself, undefined. Imagine you hold a single unbroken thread in your hands. One end is the past, the other is the future. You can feel the tension in it, the simple, profound logic of it. What has happened leads to what is happening now. What is happening now will lead to what is yet to come. This thread is the most fundamental law in the cosmos. It is more ancient than matter, more foundational than gravity. It is the principle of causality. Now imagine a pair of scissors that could sever that thread. A velocity so extreme, so forbidden that it allows you to snip away a piece of the past, to rearrange the sequence of events that led to your own existence. This is not merely a philosophical puzzle. It is a prescription for the end of everything. The moment we break the light-speed barrier, we do not just invent a new form of travel, we fashion those scissors, and we threaten to cut the thread that holds reality together. The first casualty of this impossible speed is not a place but a concept, the very idea of a coherent story for our universe, because if a signal, a ship, a single particle can outpace light, it gains a terrible power, the power to arrive before it departed, the power to deliver an effect before its cause has occurred. This shatters the universe into a billion contradictory fragments. Think of all the information in the cosmos as a single monumental library. Every book is a history of a star, a galaxy, an atom. Each sentence follows the last, each chapter builds on the one before. Causality is the librarian ensuring every volume is written in order, from page 1 to the end. But a faster-than-light message is a rogue entry. It is a sentence from the final chapter suddenly appearing on the first page. It is a conclusion without a premise, a death notice for a character who has not yet been born. How would the cosmic story accommodate this? It can't. The narrative would collapse into gibberish, a star that explodes before it has finished fusing hydrogen in its core, a planet that transmits a record of its own destruction, a millennium before the asteroid that will strike it has even formed. This is not just a problem of logic, it is a crisis of physical information. Information to a physicist is not just data, it is a real physical quantity, as fundamental as energy or mass. It dictates the state of every particle, the curvature of space-time, the fate of black holes. The laws of physics are in essence the rules governing how this information evolves and interacts. And the supreme rule, the meta-law that governs all others, is that information cannot travel backward in time. It cannot create a paradox. A superluminal object is a paradox made physical. It carries information about an event in the future back into the past. This information then alters the past, creating a new future, a future from which that original message might never have been sent. We are now in a dizzying loop, a cosmic inconsistency from which there is no escape. The universe is forced to contain two mutually exclusive realities at the same time. The past in which the message was received and the past in which it was not. The library now contains two versions of the same book, with contradictory endings. Which one is real? The answer is terrifying: neither. The system crashes. The very concept of a single definitive timeline dissolves. And this is only the beginning of the devastation. The true horror begins when we look deeper beneath the story of stars and galaxies, down into the seething, violent realm of the quantum world. Here in the substrate of reality, the violation of causality is not a philosophical problem. It is a trigger for absolute annihilation. To understand why, we must journey into the void, into the so-called emptiness between particles, the vacuum of interstellar space. But this emptiness is a profound illusion. The quantum vacuum is not empty at all. It is a roiling, effervescent ocean of latent energy. a place where particles of matter and antimatter are constantly bursting into existence, and an instant later annihilating each other. These are called virtual particles. They are the fleeting ghosts of reality, borrowing their existence from the future. They wink into being interact and then vanish back into the nothingness from which they came. They do this so quickly, so ephemerally, that they obey a principle of uncertainty. They can borrow a tiny amount of energy from the vacuum, so long as they pay it back almost instantly. The universe in its wisdom allows for this temporary cosmic loan, but the repayment schedule is brutally enforced, and the enforcer is the speed of light. The time a virtual particle can exist is strictly limited by how far it could travel at light speed before it must disappear. This cosmic speed limit keeps the borrowing and lending in balance. It ensures the vacuum on average remains stable. It keeps the ghosts in the machine. Now introduce a real particle traveling faster than light, an intruder moving at a velocity forbidden to the ghosts themselves. This superluminal particle can now interact with one of these virtual pairs, but because it is moving backward in its own time stream, it can do something impossible. It can give energy to one of the virtual particles, let's say the electron. This injection of energy makes the virtual electron real. It promotes it from a fleeting phantom into a solid citizen of our universe. It no longer has to vanish. But what of its antimatter partner, the virtual positron? It is still bound by the old rules. It must repay its energy debt, so it seeks out another particle to annihilate with. Perhaps it finds a different nearby electron. They collide and vanish in a flash of light. A transaction has occurred, but look closely at the ledger. It is profoundly wrong. Our faster-than-light particle created a real electron. Then a nearby unrelated electron was destroyed. The net result: the universe has lost an electron. But what did our superluminal particle lose in this transaction? Because it travels backward in time from its perspective, it absorbed the energy from the positron's annihilation before it created the real electron. It gained energy. Think about the implications. A particle that by participating in the destruction of matter gains energy. It is a process that feeds itself, a cosmic fire that creates its own fuel. The faster-than-light particle now has even more energy than before. It can repeat the process, creating another real particle from the void and gaining still more energy in the process. This is not a stable interaction. It is a runaway chain reaction at the quantum level. A single superluminal particle streaking through the vacuum would leave a wake of destruction and creation behind it. It would act like a catalyst, turning the latent energy of the void into a torrent of real particles and radiation. The vacuum itself would begin to boil. The nothing that separates the stars would ignite. This runaway energy state is a direct consequence of chronological perversion. By reaching into the past, the particle has engineered a quantum Ponzi scheme. It borrows energy from a future event, the annihilation of a particle, and uses it to create a present reality. The books never balance. The energy debt is never repaid. Instead, it multiplies. This cascade of energy would propagate outwards from the particle's path. It would spread not at the speed of the particle, but at the speed of the paradox itself, instantaneously in a sense, because the effect is rippling backward and forward through time simultaneously. The quantum field, the very foundation of existence, would be whipped into a frenzy. Its placid surface, normally disturbed only by the gentle ripples of virtual particles, would become a raging tempest. The energy density of space-time in that region would skyrocket towards infinity. And when the energy of the vacuum reaches such an impossible level, something has to give. Not just matter, not just energy, but the very nature of space-time itself. We have witnessed what happens when matter is put under extreme pressure and temperature. Ice melts into water. Water boils into steam. These are known as phase transitions. The substance is the same H2O, but its properties, its rules of behavior, are radically transformed. Physicists now believe that space-time itself can undergo phase transitions. The quantum vacuum, the fabric of our reality, is just one possible state, one phase of existence, and like ice, it can be heated until it melts, or boils. The runaway energy cascade from a single faster-than-light particle could be the trigger. It could provide the unimaginable heat needed to initiate a phase transition in the vacuum. Space-time would begin to change its fundamental state, and we have absolutely no idea what lies on the other side of such a transformation. It would be like an ice crystal trying to comprehend the nature of steam. The new phase of space-time might have entirely different laws of physics. Perhaps in this new state the force of gravity is repulsive. Perhaps the electromagnetic force no longer holds atoms together. The very constants of nature that choreograph the cosmic dance could be altered. The fine structure constant which governs the strength of light and matter interactions could shift. Atoms would instantly dissolve their electrons flying free. Stars would extinguish in a nanosecond, their fusion reactions failing. The gravitational constant could change, causing planets to be flung from their orbits and galaxies to fly apart. This would not be an explosion in the conventional sense. An explosion happens within space. This would be an explosion of space. A bubble of this new terrifying vacuum would form, expanding at nearly the speed of light, and everything it touched, every star, every planet, every galaxy would be rewritten. Its physical laws would be erased and replaced with a new alien physics, a physics in which our form of existence might be an impossibility. We would be transformed into something utterly unrecognizable. Our reality, our cosmos, would be consumed by this expanding sphere of new rules, a wave of existential annihilation washing over the universe. But even this might not be the most bizarre outcome. Some theories suggest that such a phase transition could create forms of matter so strange they defy our current understanding. One potential byproduct is something called exotic matter. Matter with negative mass, or negative energy density. This is the theoretical ingredient needed to create and sustain a stable wormhole, a tunnel through the fabric of space-time, a shortcut across the cosmos. But these would not be the controlled, elegant gateways of science fiction. The vacuum decay would not create one stable wormhole. It would tear space-time into a chaotic, frothing foam of them. Countless microscopic and perhaps even macroscopic tunnels would rip open at random, connecting arbitrary points in space and in time. Our universe would no longer be a smooth, continuous fabric. It would become a labyrinth, a cosmic Swiss cheese riddled with unpredictable portals. Step through one, and you might find yourself in the core of a distant star. Step through another, and you could emerge 1 billion years in the past on the other side of the universe. Causality, already wounded by the initial superluminal act, would now be murdered 1 trillion times over. Every wormhole would be a new source of paradox, a new feedback loop of inconsistency. Imagine a beam of light entering one of these chaotic wormholes. It could be looped back on itself, arriving at a point in its own past. It would meet itself, amplifying its own energy, creating a feedback loop that would quickly become a laser of infinite intensity, a time laser that would incinerate the very structure of space-time around it. The universe would become a funhouse of impossible energies and temporal nightmares, a place where history is no longer a line but a tangled burning knot. Every point in space and time would be perilously, unpredictably connected to every other. The past, present, and future would bleed into one another. The stability of existence would be gone. There would be no safe place, no coherent moment, only a ceaseless, churning chaos. a reality that is constantly rewriting and erasing itself moment by moment. This is the ultimate price of breaking the universe's most sacred law. The speed of light is not an arbitrary speed limit like one you might find on a highway. It is not a technological barrier we are destined to overcome. It is a fundamental pillar of cosmic sanity. It is the firewall that protects the integrity of the timeline. It is the bulwark that holds back the raging sea of quantum paradox. It is the law that ensures the universe has a coherent story to tell, a story of cause and of effect. To travel faster than light is to declare war on the arrow of time. It is to attack the very logic of existence. And the result of that war is not victory, not progress, not exploration. It is the dissolution of everything. A universe where the thread of causality is cut does not become free. It simply unravels into an unrecognizable and eternal chaos. A storm of paradox from which no new order could ever be born. The end of everything might not arrive with a roar. There may be no final blinding flash of light, no cataclysmic explosion that shatters galaxies. The ultimate destruction of the universe could be quieter, more insidious. It might be the sound of a single fundamental rule of existence snapping in two. We have spent our journey together on the edge of an abyss, peering into the consequences of infinite mass of time, running in reverse of paradoxes that curdle logic. We have treated the speed of light as a cosmic speed limit, a barrier to be overcome, a challenge for our ingenuity. But what if we have been looking at it all wrong? What if that inviolable velocity, that constant c, is not a prison wall keeping us confined? What if it is a foundation, the single load-bearing pillar holding up the entire architecture of reality? And our desire to shatter it is a desire to bring the whole cathedral of the cosmos crashing down upon ourselves. The destruction we are contemplating is not one of annihilation. It is a destruction of coherence, of sense, of the very logic that allows a universe to be a universe at all, instead of an unknowable, ever-shifting chaos. It is the unraveling of the source code of existence. Imagine the universe as a vast, intricate piece of music, a symphony of unimaginable complexity playing since the dawn of time. Its score is written in the language of mathematics. Its notes are the fundamental laws of physics. Gravity is a recurring theme, a deep, resonant bass line that holds the celestial bodies in their elegant dance. Electromagnetism is the soaring melody carried by light itself, connecting every corner of the cosmos in a web of information. The strong and weak nuclear forces are the intricate harmonies, the subtle rules of interaction that allow stars to burn and matter to hold itself together. This symphony is what we call reality. It is predictable, beautiful, and governed by an unshakable internal logic. A star collapses, a supernova blooms, a planet orbits, life emerges, cause and effect, the unwavering rhythm of the cosmic score. Now imagine a single musician deciding to play an impossible note, a note that is not in the score, a chord that defies the key, a sound so dissonant, so fundamentally wrong that it doesn't just clash with the music, it begins to corrupt the score itself. The notes on the page begin to writhe, to rearrange themselves. The rhythm falters, the themes dissolve into a cacophony. The symphony of existence collapses into meaningless noise. This is the nature of the threat. Traveling at the speed of light or beyond is that impossible note. It is an act so profoundly at odds with the universe's operating principles that it does not simply break a rule. It proves that the rules themselves are meaningless. And in a universe without rules, nothing is stable. Nothing is certain. The very concept of is becomes a flickering candle in a hurricane. The first thread to be pulled from this cosmic tapestry is the most crucial. It is the principle that underpins our every thought, our every action. It is the law that separates yesterday from tomorrow. Causality. The simple, profound idea that a cause must always precede its effect. You strike a match, and then a flame appears. A star exhausts its fuel, and then it collapses into a black hole. This is the universe's arrow of time, its fundamental grammar. It is the chain of events that makes history possible, that makes learning possible, that makes you. Your birth was a consequence of events that came before it. Your every decision creates a wave of effects that will ripple into the future. This relentless forward march of consequence is what gives reality its narrative, its story. But as we have seen, faster than light, travel is functionally equivalent to traveling backward in time. It creates pathways in space-time, closed time-like curves where an object can return to its own past. Science fiction has long played with the paradoxes this creates. The grandfather paradox is the most famous. What happens if you travel back and prevent your own grandfather from meeting your grandmother? You would never have been born to make the journey in the first place. It is a perfect, unbreakable loop of contradiction. For decades, we have treated this as a philosophical game, a sign that such journeys must be impossible because they lead to absurdity. But we have failed to consider the alternative. What if the universe doesn't have a built-in protection against absurdity? What if, when confronted with a true paradox, it simply breaks? The presence of a single object moving faster than light would not just be a local anomaly. It would be a declaration to the entire cosmos that the sequence of cause and effect is now optional. Imagine a region of space where this law has been violated. An effect could now create its own cause. A star could explode, and the shock wave from that explosion could travel back in time to trigger the stellar instability that caused the explosion in the first place. This isn't just a loop, it is a self-generating catastrophe. It's a perpetual motion machine of destruction, creating infinite energy from a paradox feeding on its own impossible existence. The law of conservation of energy, the rule that energy cannot be created or destroyed, would be shattered into a million pieces. Entire galaxies could flare into existence from nothing, powered by the fallout from a temporal contradiction. Or just as easily they could be erased, their energy debt called in by a history that never happened. This corruption of causality would spread, not like a wave but like a virus, infecting the operating system of reality. Space-time would become riddled with these pockets of illogic, places where the past is not fixed, where the future is not yet decided, and where the present has no meaning. History would cease to be a static record. It would become a churning, boiling sea of possibilities, constantly rewriting itself. Your own existence could flicker in and out, a consequence of a past that is no longer guaranteed. The very ground beneath your feet, the atoms in your body, are all products of a long, unbroken chain of causality stretching back 13.8 billion years to the Big Bang. If that chain is broken anywhere, the integrity of the entire structure is compromised. The universe we know, the one with a past, present, and future, would cease to be. It would be replaced by a maelstrom of temporal chaos, an endless, senseless now, where anything can happen and therefore nothing truly matters. But the unraveling does not stop with time. It attacks the very stage on which the cosmic drama unfolds, space-time itself. Einstein's great revelation was that space and time are not separate. They are a single four-dimensional continuum, a fabric. This fabric is dynamic. It can be bent, stretched, and warped by mass and energy. This warping is what we feel as gravity. A planet does not orbit the sun because of a mysterious invisible rope. It follows a straight line through a region of space-time that has been curved by the sun's immense mass. The laws of relativity are the weaving instructions for this fabric. They dictate its texture, its strength, its behavior. And at the heart of these instructions is a single immutable constant, the speed of light. It is the conversion factor between space and time. It is the ultimate measure of the fabric's rigidity. To approach this speed requires an infinite amount of energy, causing an object's relativistic mass to climb toward infinity. Its length in the direction of motion contracts towards zero. These are not just mathematical tricks, they are symptoms of space-time under unimaginable strain. It is the fabric being stretched to its absolute breaking point. So what happens if you succeed? What happens if you deliver that final impossible push and cross the threshold? The fabric does not just stretch, it tears. We must abandon our simplistic notions of what a tear in space-time would be. It would not be a shimmering portal to another dimension. It would not be a gateway to a wondrous new cosmos. A tear in space-time would be a place where space-time ceases to exist. It would be a raw, naked singularity, but not the kind hidden behind the safety of a black hole's event horizon. This would be an exposed wound in the body of the universe. A point of infinite density, infinite curvature, and zero size unleashed upon reality. It would be a place where the laws of physics are not just broken, they are absent. Inside such a lesion of reality, there is no space, no time, no up, no down. The very concepts of distance and duration would have no meaning. It would be a point of pure, unadulterated chaos, a cosmic abyss from which no information could ever escape and into which all order would inevitably fall. The emergence of even one such stable, naked singularity would be a death sentence for the universe. Its gravitational influence would be unpredictable, chaotic. It wouldn't just pull things in. Its influence could rewrite the nature of gravity in its vicinity. Planets could be ejected from their solar systems at random. Stars could find their fusion reactions snuffed out or accelerated into catastrophic detonations. The delicate balance of cosmic structures from galaxies to the great cosmic web itself would be utterly disrupted. These tears would be like cancers in the tissue of the cosmos. They could spawn more singularities, a cascade of cosmic corruption spreading from the initial violation. Regions of the universe would effectively become quarantined, excised from ordered reality, their light forever trapped in a maelstrom of incomprehensible physics. Our night sky, currently a testament to an orderly and predictable cosmos, would begin to develop blank spots, dark, silent patches where the laws of nature have failed, where the fabric of existence has been torn asunder, leaving only an unseeable, unknowable void. And this leads to the final, most fundamental collapse, the breakdown of the universe's most sacred and foundational principles, the laws of conservation. We live in a cosmos that, for all its violent spectacle, is meticulously balanced. Energy cannot be created from nothing, nor can it be destroyed. It only changes form. The chemical energy in a star's fuel becomes the radiant energy of light and heat. The potential energy of a collapsing gas cloud becomes the kinetic energy of a spinning protostar. This single elegant rule prevents the universe from descending into madness. It ensures stability. It prevents runaway chain reactions of creation or annihilation. It is the universe's guarantee of its own continued existence. But a universe where the light-speed barrier can be broken is a universe where this guarantee is void. As we've seen, the paradoxes of time travel could create energy from nothing. Theories about hypothetical faster-than-light particles or tachyons also flirt with this existential danger. Some mathematical models suggest that tachyons could possess imaginary mass, leading to bizarre situations where they could gain energy by slowing down, potentially releasing an infinite amount of it. If a massive object like a spaceship could be engineered to punch through the light barrier, it would become a gateway for these violations to enter our reality. It would become a conduit for chaos. Imagine a localized zone where energy conservation no longer applies. What would that look like? Perhaps it would manifest as a false vacuum decay event, Our universe exists in a stable, low-energy state, the true vacuum. But if a region were to suddenly decay into an even lower, more fundamental energy state, it would create a bubble of new physics, a new reality with different fundamental constants, different laws. This bubble would expand at the speed of light, and everything it touched, every star, every planet, every atom, would be instantly and irrevocably converted into this new state. Our form of existence would be overwritten, erased. A single act of breaking the light barrier could be the trigger, the pinprick that bursts the bubble of our reality. The universe wouldn't be destroyed in fire, but rewritten in a new alien language that has no place for us or for anything we have ever known. So let us synthesize these cascading failures. Let us stand here at the climax of our investigation and gaze upon the true face of a destroyed universe. It is not an empty void. It is something far, far worse. It is a cosmos where the chains of causality have dissolved. An event no longer needs a reason to occur. A sun might vanish from the sky not because it has died, but simply because the history that led to its creation has been retroactively erased by a temporal paradox half a universe away. A new star with a different chemical composition and a different planetary system might appear in its place, born from nothing. It is a universe whose physical stage, space-time, is fractured and diseased. Great tears in the fabric bleed pure chaos, their unpredictable gravitational tides flinging galaxies against each other like skittles. Space is no longer contiguous. To travel from one point to another might mean navigating a minefield of spatial discontinuities, regions where distance itself is a fluid, unreliable concept. The straight path of a light beam, the very foundation of our ability to observe the cosmos, can no longer be trusted. The sky would become a funhouse mirror of distorted starlight images from the past and future, overlapping in a meaningless collage. It is a universe where the fundamental accounting of energy is bankrupt. Conservation laws are a historical footnote. Vast energies can erupt from nowhere, incinerating worlds in an instant. Or the energy of a star could simply leak away into nothingness, leaving a cold, dark husk for no discernible reason. The very atoms that make up your body are held together by forces and energy balances that are no longer guaranteed. Matter itself could lose its integrity, its structure dissolving as the rules that bind it flicker and die. This is the ultimate destruction. It is not the death of matter and energy. It is the death of pattern, the death of law, the death of information. The universe would cease to be a cosmos, a place of order, and would revert to a primal, seething chaos. A reality where science is impossible because there are no consistent phenomena to study. Where knowledge is impossible because there is no stable truth to be known. Where life and consciousness are impossible because they require a predictable, stable environment in which to evolve and exist. The universe wouldn't just be gone, it would be rendered incomprehensible. And an incomprehensible universe, one without logic or reason, is for all intents and purposes no universe at all. So we are left with a final, profound and humbling realization. The speed of light is not a cosmic frustration. It is not a limit to be angrily defied. It is the ultimate act of cosmic preservation. It is the law that protects all other laws. It is the sacred covenant that ensures a star that rises in the east will continue to do so. It is the principle that guarantees the past is immutable and that our actions today will shape a genuine tomorrow. It is the wall that holds back the ravenous tide of chaos, of illogic, of non-existence. We look to the stars and dream of breaking our bonds, of traveling faster than light to reach them. But perhaps the greatest wisdom we can ever attain is to understand that the very laws that seem to confine us are the same laws that give us a universe to dream in at all. We have journeyed to the absolute edge of possibility. We have stared into the abyss of a universe torn asunder, a cosmos where time rebels and reality itself dissolves into paradox. Our quest began with a simple, primal human dream to travel faster, to slip the gravitational chains of our small world and race to the stars. Yet with every step we found that this dream collides with a law so fundamental, so absolute, it seems less like a rule and more like the very thought from which the universe sprang, the speed of light. For generations we have seen it as a barrier, a cosmic cage, the ultimate frustration for a species born with infinite curiosity. But what if we have been looking at it all wrong? What if this ultimate speed limit is not a prison wall, but the very foundation of our home? What if the universe's most profound prohibition is in fact its most sacred act of protection? Journey ends here, not with an answer for how to break the law, but with the staggering revelation of why we must never succeed. The speed of light is not merely a number scribbled in a textbook. It is the universe's fundamental rate of exchange. The pace at which information can propagate, at which reality can update itself. It is the grand cosmic metronome, and every particle, every force, every wave in existence dances to its unyielding rhythm. To move faster than light is to attempt to dance faster than the music of reality. It is an act of profound dissonance, an insurrection against the cosmos, and the consequence is not a speeding ticket. It is the complete and utter collapse of the symphony. Consider the bedrock of your own experience, cause and effect. A glass falls and then it shatters. A star collapses and then a black hole is born. This logical linear progression is the essence of a comprehensible universe. It is the thread of reason that allows us to build theories, to make predictions, to understand our past, and to contemplate our future. This entire magnificent chain of causality is policed by a single guardian, the constancy of light speed. Because nothing can travel faster than light, no effect can ever precede its cause. Imagine for a moment a universe without this guardian. A reality where you could outrace the light from a distant event. You could receive a reply before you ever sent the message. You could witness a supernova's brilliant death in the sky, then travel back along its path to watch the star still shining peacefully, unaware of its own imminent demise. The past, present, and future would bleed into one another. It would be a dementia of space-time, a maddening chaos where history is not written but endlessly scrambled. The arrow of time would not just be broken, it would shatter into 1,000,000 pieces, each pointing in a different, impossible direction. This is the coherence that Creed preserves. It is the sentinel of sanity, and its role extends far deeper into the very geometry of existence. Einstein revealed to us a universe where space and time are not separate arenas. They are interwoven into a single dynamic fabric, space-time, and the thread that stitches them together, the conversion factor that defines their relationship, is the speed of light. It is the c in E = mc², the constant that tells space how to bend and tells time how to flow. It is the loom upon which the tapestry of our four-dimensional reality is woven. To surpass this speed would be to take a blade to that loom. It would be to sever the connection that gives the universe its structure. Space would untether from time. The very concepts of distance and duration would lose their meaning. How far is a light year if you can cross it in an instant? How long is a year if you can experience it before it begins? Space-time would cease to be a cohesive whole. It would become a fractured, nonsensical landscape of isolated points and moments, a shattered crystal with no discernible pattern. The universe we know would simply cease to exist, replaced by a ghost of disconnected coordinates. The speed of light doesn't just limit our motion through the cosmos, it holds the cosmos together. This guardianship extends to the most fundamental components of our world, matter and energy themselves. The most famous equation in all of science, E = mc², is a pact, a covenant between mass and energy with C as the immutable witness. It tells us that a tiny amount of matter is a reservoir of immense energy. It is the principle that powers our sun, that fuels the stars, and that governs every nuclear reaction in the universe. The stability of this equation, the very predictability of our physical world, hinges on C being an absolute unwavering constant. If you could exceed it, if you could somehow force your velocity beyond that limit, the equation breaks down. As you approach light speed your mass curves toward infinity. You demand an infinite amount of energy to go any faster. But what happens if you succeed? The mathematics screams paradox. The energy of your vessel would become imaginary, a nonsensical concept. The very distinction between what is real and what is impossible would blur and fade. The universe's energy budget, a meticulously balanced system for over 13 billion years, would be rendered meaningless. Would new universes spontaneously erupt from the violation, or would our own be drained into the void, its energy stolen by an object moving at an illicit velocity? We don't know. But we know that we would be tampering with the source code of creation. It is an experiment for which there could be no observers left to record the outcome. And so we find ourselves standing before a profound cosmic irony. The universe appears to be built upon a foundation of incredible precision. Its laws and constants are not arbitrary. They seem to be exquisitely fine-tuned. If the force of gravity were slightly different, galaxies would never have formed. If the strong nuclear force were a fraction, weaker stars could never ignite. And if the speed of light were different, the chemistry required for life might be an impossibility. We are afloat in a cosmos that seems perfectly calibrated for existence, a delicate, intricate mechanism of unimaginable scale. Our dream of faster-than-light travel is in this context a dangerous impulse. It is the desire to take a hammer to the most precise clock ever made just to see if we can make the hands spin faster. We are like characters in a book who, frustrated with the pace of the plot, decide to tear out the pages. The very act of rebellion against the rules of our reality could be the ultimate act of self-erasure. The great barrier that seems to confine us to our cosmic neighborhood, the vast uncrossable gulfs between the stars, this is the very same architecture that guarantees we have a home at all. The walls of the supposed prison are also the walls of our sanctuary. Does this mean the dream must die? Does this mean humanity is forever bound to this single star system, destined to watch the grand celestial drama unfold from an immense distance, never to visit our stellar neighbors? Perhaps not. For the human spirit, when faced with an insurmountable wall, does not always try to break through it. Sometimes it looks for a door. Our ambition, our relentless drive to explore, is not extinguished by this realization. Instead, it is refined. It is elevated. Our quest is no longer one of brute force, of breaking a cosmic law. It becomes a quest for elegance, for subtlety, a search for a cleverer way to traverse the void. This new understanding must now inform every aspect of our scientific endeavor. As we peer into the deepest mysteries, we do so with a newfound sense of reverence. When we study the perplexing enigma of dark energy, the mysterious force that is accelerating the expansion of the universe, we are not just cataloging the cosmos, we are observing the behavior of space-time itself on the grandest scales. We are learning about its elasticity, its fundamental nature, and perhaps discovering clues about its hidden geometries. This knowledge is no longer merely academic. It is a crucial part of the safety manual for any future interstellar civilization. When our theoretical physicists sketch out equations for quantum gravity, attempting to unify the world of the very large with the world of the very small, they are treading on sacred ground. They are probing the operating system of reality, seeking to understand the rules that govern the pixels of space-time at the Planck scale. In their symbols and theories lie the potential for either cosmic ruin or a path to the stars that honors the integrity of the universe. The scientist of the future is not just an explorer. They are a guardian, a custodian of cosmic law, tasked with navigating our species' ambitions without shattering our reality. The stakes have been raised to the absolute maximum. So, if we cannot smash the light barrier head-on, are there other avenues? Are there back doors in the architecture of the cosmos? The answer, whispered from the deepest implications of Einstein's own theories, is a tantalizing, perhaps. The solutions lie not in moving through space faster than light, but in fundamentally redefining the journey itself. They are proposals that work with the laws of physics, not against them. They are attempts to be clever, to find a loophole in the universal contract. Consider the concept of a warp drive, an idea given life by the physicist Miguel Alcubierre. It is a vision of travel not by propulsion but by distortion. The ship itself would rest inside a bubble of flat, undisturbed space-time. It would, from the perspective of its crew, be perfectly still. It would never locally break the speed of light. Instead, the engine would manipulate space-time itself. It would compress the fabric of space in front of the vessel and expand the fabric of space behind it. The bubble containing the ship would then be carried along on this wave, like a surfer riding a ripple in the cosmic ocean. The ship is not moving through space. Space itself is moving around the ship. The local speed limit is never violated. The laws of causality inside the bubble remain perfectly intact. It is an audacious, mind-bending proposal that in theory allows for transit between 2 points at a speed that is effectively faster than light without ever actually breaking the luminal speed. Of course, the challenges are monumental. It would require a form of exotic matter with negative energy density, something we are not even sure can exist. But it represents a profound shift in thinking, a move away from confrontation with the laws of nature and towards a partnership. Then there is an even more spectacular possibility, the wormhole. Also known as an Einstein-Rosen bridge, it is a theoretical shortcut, a tunnel carved through the very heart of space-time. Imagine the universe is a vast sheet of paper. To travel from one side to the other, you would have to crawl across its entire surface. But what if you could fold the paper, bringing your origin and your destination right next to each other? And what if you could then punch a hole through, creating a direct path? That is the essence of a wormhole. It is a conduit connecting two vastly distant regions of space, or even time. By entering one end, you could emerge from the other moments later, having bypassed the intervening light years of empty void. Once again, your ship never locally travels faster than light. You are simply taking a path that is radically shorter. You are exiting the cosmic highway and taking a secret, unmapped back road. Like the warp drive, the obstacles are immense. Keeping a wormhole stable and traversable would require titanic amounts of energy and likely that same elusive exotic matter. But as a concept, it is a testament to our enduring hope. These are not fantasies of breaking the rules. They are sophisticated, respectful attempts to navigate within them. They are the dreams of a species that has matured, that has gazed into the abyss of cosmic annihilation and stepped back humbled. We have learned that the universe has non-negotiable terms, and our future among the stars depends on our ability to read the fine print. Our quest for interstellar travel has become a metaphor for our own evolution. We began as a young species, dreaming of brute force, of raw power, of conquering the cosmos by shattering its limits. But we have discovered that such a path leads only to ruin. Now we must become a species of wisdom and elegance. Our destiny may not be to conquer, but to comprehend. to understand the intricate legal system of the cosmos so profoundly that we can navigate its corridors without triggering its alarms. The ultimate journey, it seems, is not just a physical one across the stars, but an intellectual and spiritual one into the very heart of physical law. The speed of light, which once seemed to be a lock on our cage, has revealed itself to be a key. It is a signpost pointing us away from the path of self-destruction and towards a deeper, more meaningful relationship with the universe. It teaches us that we are not separate from the cosmos, but an intrinsic part of it. Its laws are our laws, its stability is our stability, and its fragility is our own. The dream of the stars is not dead, it is reborn. It is now a wiser, more patient, more reverent dream, a dream not of speed but of understanding. And perhaps in that understanding we will finally find our way to become true citizens of the galaxy, not as conquerors who broke the ultimate law, but as inheritors who were clever enough to find a way home.